The case for declarative agents. If you've been building with AI agent frameworks lately, you've probably felt the frustration. Today, I want to make the case that we've got the abstraction layer wrong and that declarative is the way forward.
If you've tried to take a LangChain agent to production, you know this pain. The abstraction promises to handle the heavy lifting, but the moment something goes wrong, you hit a wall. You can't see the actual prompts. You can't see the raw API calls. One team I heard from had a hidden 60-second timeout buried deep in the library that silently killed 30% of their production requests. When you abstract away the HTTP calls and prompt construction, you're hiding the exact surface area where things break.
Look at what the code actually does in an imperative agent. You're manually managing the loop. This looks simple in a gist, but in production this function explodes. You need streaming, you need rate limit handling, you need session persistence so users can refresh the page. Your business logic gets hopelessly tangled with infrastructure concerns. We've seen this movie before. Before Kubernetes, we wrote shell scripts to SSH into servers. It was imperative. Kubernetes won because it was declarative. You give it a YAML manifest describing the desired state, and the runtime figures out how to get there. Same with SQL. We don't iterate over file cursors. We write select from where and let the query optimizer handle it. The winning move is almost always describe what you want, not how to get it. Now look at the declarative alternative. Instead of writing the loop, you write a specification. Look at what isn't there. No code for streaming, no code for managing message history, no retry logic, no provider-specific API calls. The runtime handles all of that. If the runtime supports streaming, your agent supports streaming. This solves the biggest issue with current frameworks: observability. When you write imperative code, logging is your problem. You have to manually instrument every step. In a declarative model, the runtime executes the spec. It sees every block transition, every tool input, every LLM output. It generates perfect traces without you writing a single line of instrumentation code. Debugging becomes a platform feature, not a frantic grep through log files. There's another benefit: portability. Right now, a LangChain agent is locked to LangChain. If you want to move, you're rewriting code. A declarative protocol is just data. It can be version controlled, diffed, and visualized. You could even build a visual editor that lets non-engineers tweak prompts and flows without touching the runtime. The future of agents looks less like writing Python scripts and more like defining resources, similar to how we define infrastructure today. I'm not saying you can't write good agents with imperative code. You can. But you end up building your own framework to manage the complexity. The question isn't whether declarative will win. It's how long we'll spend fighting with imperative loops before we get there. Thanks for watching.